Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A-Level Mathematics 9709 Mechanics. So today we will be starting with our lecture 2.2, which is vertical motion. So far, whatever examples we have studied in our lecture 2.1, they were all related to horizontal motion, straight line motion, but horizontally. So today we will be considering about vertical motion under gravity. So let's get started. Now, when we talk about vertical acceleration, okay, then gravity also uh, comes into play, okay, because the gravitational field strength of the Earth exerts a force downwards on an object, okay, so therefore the acceleration that results due to this gravitational field strength is called acceleration of free fall or acceleration due to gravity. The force of gravity causes all objects to accelerate towards the Earth, ignoring the effects of air resistance. This acceleration is constant and does not depend on the mass of the object. So if we ignore the air resistance, okay, so what happens? Let's say that if I have a feather, okay, and if I have a brick, okay, if I have something which is as light as a feather, okay, which is actually a feather, and then I have a brick. If I ignore the effect of air resistance, or if I drop both of the objects at the same time in a place where there is no air resistance, then both of them are going to fall with the same acceleration. Okay, that is what we call acceleration due to gravity. And why is that? Because since there is no there is no air resistance, right? So that allows the objects to fall with the same acceleration, which is the acceleration caused by the Earth's gravity, the Earth's gravitational pull. Okay, now when considering the Earth, the acceleration due to gravity is represented by the letter g, and its approximate value is 9.8 meters per second squared. Okay, now different on different planets or on different stars, this gravitational field strength, it varies. Okay, so like for example, at Moon it is about 1.6 meters per second square. On Earth it is 9.8 meters per second square. Even the actual value varies very slightly from place to place. So like even on Earth at different points, okay, there might be a couple of a couple of differences between the values. So for example, maybe a value at the mountain's peak might be a bit different than on the ground or underground. Okay, or maybe it's maybe in the sea or something. So but it won't be too much of a difference. It would vary very slightly, but it would be very close to approximately 9.8 meters per second square. So in mechanics, the value that we use for our acceleration due to gravity is 10 meters per second square. We use the rounded value. Okay, so be very sure that you understand this. Maybe some of you who are from physics background, they might be using 9.81, I think. So that value is not supposed to be used in mechanics. In mechanics, you're supposed to use 10 meters per second square. Okay, as gravity acts downwards, care must be taken when using g. So this value of gravity, that is represented by g. If the upwards direction is taken as positive, okay, so let's say that if I throw a ball upwards, even though the ball is moving upwards, but the acceleration due to gravity is still acting downwards, right? So that would have a negative value of minus 10 meters per second square. Okay, let me repeat that. If an object is moving upwards, okay, it's still the acceleration due to gravity is acting downwards. Therefore, the value will be minus 10 meters per second squared. And if the direction is already downward, so let's say a falling object, okay, an object is falling from let's say a ball, a person drops a ball from the top of a building. So the ball is falling down, okay, and the acceleration is also downward, so we are taking downward as the positive. Therefore the value of g will be positive 10 meters per second square. All right, sign convention, we've already discussed this. Okay, so let's move ahead. A ball is thrown vertically downwards from the top of a building at a speed of 2 meters per second. Okay, there's another thing that I want to highlight over here. It says the ball is thrown vertically. When you throw something, so obviously you're throwing that object with a certain speed, so with a certain velocity. But if the question was a ball is dropped vertically, okay, that means it was you just held the ball and you just released it. You're not putting any effort into it. At that point, the initial velocity will be zero. So be careful to read the question whether it says the ball is thrown, the ball is projected, okay, that also means the same thing, or the ball is dropped. Dropped means the initial velocity is zero. Okay, so the ball is thrown with an initial velocity of 2.5. If the height of the building is 20 meters, find the speed with which the ball hits the ground. So by the time it has traveled 20 meters, okay, and it reaches the ground, we need to calculate what will be the final velocity. So here we have the initial velocity u, we have the displacement 20, we need to find v, but these are only three variables, right? So understand this, that since this is a vertical motion, the acceleration will be g. Okay, so also if you need to understand this, it will be a good idea to draw a simple diagram. So this is the building, the ball is here, it has been thrown, so it is moving downwards, and we are taking down as our positive. So this is the point where we need to find the final velocity. So here, write down the values that we are using, and also mention in the question that you're taking downward as positive. So we can say that take down as positive. So S will be 20, U is 2.5, V is what we need to find, and acceleration will be 10. So you can use V square equals U square plus 2AS, and therefore your answer will be 20.2 meters per second to 3SF. Okay, now it says calculate the time taken for the ball to reach the ground. So again, you can use the given values or you can use this value as well, but definitely I'm going to go with this. So that will be S is equal to ut plus half at squared, and we'll be able to get the same answer, which is 1.77. Okay, so let me use that as well. So if I use S is equal to ut plus half at squared, okay. All right, now the only difficulty you might have in this is that you're going to get an equation in a quadratic form. Okay, so that would mean solving like that would mean that you have to do some additional steps to identify what the value of t is going to be. One of them will be a negative value, the other is going to be a positive value. So definitely you're going to use a quadratic formula for this purpose, and therefore your answer is going to be something similar. Okay, so you can use this method, or if you're comfortable with this one, or if you're confident that you have done the previous part correctly, then you can use this value. There's no harm in that. All right, so that was question number one. A ball is thrown vertically. Also, there's something important is written here. The final answers are rounded to 3SF, but do not use rounded answers in another calculation. So for example, over here, our final answer to part A was given as 20.2 meters per second. But does that mean that if I need to use this value, I have to use this value? Absolutely not. You need to use something which is at a greater accuracy. So maybe you can use 20.1556 or 20.157. Okay. If your final answer is given to 3SF, then use a value of at least 4SF or 5SF. Okay, so over here they've actually used at a much greater accuracy, but what you can do is at least use a value which is at least 4SF or 5SF. Example 6, a ball is thrown vertically upwards from ground level at a speed of 15 meters per second. Find the greatest height reached by the ball. Okay, now when you throw a ball, let's say that this is my ball, and if I throw it, so you have noticed the ball makes a shape of a parabola like this, right? So if I draw it, this is my ball, okay, and I'm throwing it, so it goes there. Then before it comes back, there is a moment where it stops. just for like there is a moment, momentarily, the ball, there's a moment where the ball comes at instantaneous rest. Okay, so what does that mean? Before it comes back down, it stops there at the greatest height. So that means at this particular point, v is equal to 0. At that point, when it is at the greatest height, at that point v is equals to 0. So if let's say u is equal to 15 meters per second, okay, and you need to find the greatest height that the ball has reached. Okay, so that is s that we need to find. What fourth variable we can take into account? Since this is a vertical motion, we can take acceleration to be minus g, because now notice that our direction of motion is upwards. Okay, so if I've taken upwards as my positive, the acceleration is still acting downwards regardless of whether the object is moving from whether the object is moving upwards or downwards. Acceleration due to gravity will be minus, okay, because it is acting down. So these are the four variables that we have taken into account. So we can also draw a diagram something like this, right, similar to what I've drawn over there. So now s is equal to the question mark, because this is what we need to find. Use 15, v equals to 0, and a is equal to minus 10. Therefore, you can use v square equals u square plus 2as. So s is equal to 11.25 meters. All right, part B, the time taken for the ball to return to ground level. So you need to find that how much time it takes for the ball to return to ground level. So similarly, in this case, what we're going to do is s is equal to 0. Why? Because we are now considering that the ball starts from the ground, it goes all the way up, reaches the greatest height, and then comes back down. So when it comes back to the ground, how far is it from its starting point? Okay, now we're assuming that it goes up like this and comes back to this starting point. So that means the displacement is 0. Got it? So s is equal to 0. Initial velocity is 15. V is not needed. A is minus 10, and you can find time. Okay. Now, definitely what we can deduce from this situation is the displacement is 0 at two instances. Once at the very beginning. So one of the values of t is going to be t equals to 0. Okay, so definitely we're going to end up with a quadratic equation. So one of them is going to be 0 and the other will turn out to be some different value. That will be the answer that we are looking for. Okay, so if we use s equals ut plus half at square, okay, you will end up with this quadratic equation. So let me work this over here. So you have minus 10 t square, sorry, this minus 10 and this 2, so they'll be simplified to minus 5. So minus 5t squared plus 15t equals to 0. I can switch them to the other side. 5t square minus 15t equals to 0. If I take 5t common, sorry, that would be t minus 3 equals to 0. So therefore, one of the answers is going to be t equals to 0, the other will be t equals to 3 seconds. So therefore, my answer will be t equals to 3 seconds. Hence, the time taken to return to ground level is 3 seconds. All right. So that is the end of our lecture number 2. And that is also the end of our chapter number 2. Okay, so in our next video we'll be going through some exam style questions. They will also have some past paper questions as well, so that will give you an idea of how exam questions look like when it comes to this chapter. So till then, take care. Assalamu alaikum.